Hi everyone, it's Dan here. We're going to look at dead testing now, so hopefully you all looked at the pre-work, the safe isolation, what to do before we start the job, who to inform, who's responsible, bits like that. So dead testing. So these are already tests that are done while there's no electricity turned on. So basic stuff, continuity, insulation resistance, your basic polarity, everything like that. So to make sure it's safe to power up, we do these tests, and then once we confirm it's safe, we do our live tests. So we're going to go through scenarios on dead tests. So again, questions. Once again, any issues, give me an email and I'll get back to you and hopefully help you. But this should clear up a few things ready for your exam, I hope. So the first question, insulation resistance, which is of course a dead test. So this one's protected by a fuse. Before you do it, what do we need to do? So this links back to the last video. So we've got to isolate the circuit, prove it's dead, a warning notice is erected. If you try and do an insulation resistance test, you're putting 500 volts through a circuit. If that circuit's got 230 volts through it, you're going to blow your tester to millions of pieces and you're going to get injured yourself as well. So isolation, turn off, lock off, warning signs, test it with your proving unit and make sure it is definitely turned off. Which of the following tests carried out to confirm accessories are correctly connected? So this is making sure that your socket outlets, the right pins are connected to the right conductors. Your light switches only switch your line conductor and not your neutral. Your MCBs turn off your line and not your neutral. Very dangerous if you turn the neutral off and leave the line flowing. So this is making sure that everything's connected up correctly. Edison lamp holes, which is screw-in type. The center pin has to be alive. The outer thread has to be neutral, because it is possible if you touch the outer thread of a lamp whilst putting it in. So if the outer thread was live, you could potentially get electric shock there. Which of the following tests would not apply to an electrical installation form part of a TNS system? So terra, neutral, separate. So this is where you've got your three conductors coming in live, neutral and earth. And the one that doesn't comply is earth electrode resistance. So earth electrode resistance is only used on a TT system. So TT system is where you've got your earth rod. We do a separate test there to make sure that the path through the ground is suitable. So bonding conductors, what sort of reading are you going to expect? So these are your main bonding conductors. So in your house, they'll go to your water, under your sink possibly, your gas, wherever that is, outside or under the stairs. So the readings we're expecting is very low reading, and we'd expect a reading of 0 to 2 ohms. This is very small considering when we look at insulation resistance tests, we're measuring in mega ohms, which are millions of ohms. So 0 to 2 ohms, as low as possible. Which of the following is a suitable method for confirming instrument function and ensuring accurate test results when using a low resistance ohm meter? So a low resistance ohm meter measures continuity. So before we do a continuity test, we should be putting the leads together and zeroing them. So we do a null test. So on your mega, it's the big yellow button, press that and it removes the resistance to your test leads. So it's basically a calculator. What it does, it calculates how much resistance is in them leads. Then when you get onto your test, it just subtracts that number away from it so you get an accurate reading, which is good. Straightforward one to remember this, guys. If the length of cable is doubled, the insulation resistance value would halve. Yeah, so insulation resistance halves. A very similar question you sometimes get is about continuity. If the length of cable is doubled, continuity would also double. So two very similar things with complete opposite answers there. Inspection testing to determine the suitability of an existing circuit is to be carried out. Which of the following tests must not be undertaken if the circuit cannot be isolated? So we mentioned this already about doing an insulation resistance test, 500 volts going through and 230 volts on the circuit. It's going to blow your tester to pieces. So insulation resistance cannot be done. Look at the other options. Continuity CPC. CPC's got no voltage going through it anyway, so it's dead. Earth fault loop impedance is a live test, and functional testing is also a live test, so you need the power there anyway. Continuity of a main protective bonding conductor may be confirmed by visual inspection where the conductor is. Now, if it's visual inspection, you've got to be able to see it, don't you? So the only option it has to be visible throughout its entire length. If you can see it, if it goes through a wall for a couple of inches and you can't see it, then it's no good. You'd have to do a proper test. So the test is a continuity test, but to get around that, just do a visual if it's visible for the full length. People choose this method because you need a long cable to do the continuity test if it's a decent run on the cable. When a number of additional circuits are connected to a distribution board, installation resistance value will decrease. So this is linking back to your level 2, guys. Basically, you've got a parallel circuit. So when you've got a distribution board, everything in there is connected in parallel to each other. So when you go back to level 2, we did resistance in parallel. The more resistors you add, the lower the reading. So the overall installation resistance is always less than the smallest resistor. So add more circuits, your installation resistance value will go down. Method for confirming the correct connection of single pole devices. So single pole device, light switch, MCB, basic stuff like that. So we do a polarity test there. It's basically you do a continuity test, check that it is your live conductor that's getting turned off and not your neutral. Which of the following is a test applicable to an installation forming part of a TT earthing system? So on a TT earthing system, we do an earth electrode resistance test. So the electric's turned off for this test because there's no earth while we do it. And we disconnect the main earth and test the cable that's going down to the earth rod and all the way back and test how good it is. We use earth spikes, you'll have done this in the class. So the earth spikes we move about and we do a few different tests to see what value we get, see if that's acceptable or not. That's it for this, guys. Any questions, drop me an email at dw.raw@mbro.ac.uk. You should fly through your exams. Watch the videos over and over again. Make sure you know all these questions. Some of these do come up. Very similar questions. They're all worded very similarly, so you should get a general idea of what sort of thing to expect. Thanks, guys.